So this question has been asked in GATE 2007. We have been given 4 processes and using SRTF, that is shortest remaining time first scheduling algorithm, we have been asked to find the total waiting time for process P2. Remember, SRTF is a preemptive scheduling algorithm. That means if the operating system wants, it can pull out a process executing with the CPU and give the CPU to another process. And what is the criteria based on which this algorithm works? This algorithm works based on the execution time or burst time. And the process which has the least burst time is scheduled first. So if I have 2 processes, one with lesser burst time than the other, the process with the lesser burst time will get hold of the CPU first. So let's see how this problem can be solved or how we could arrive at the final answer. Now, in order to solve such questions, once again, we will make use of a NAT chart. So let's see how this is done. So I'll have to make use of a NAT chart. And as always, we'll start from time 0. All these times that are given to us, these are all relative times. That means process P1 having an arrival time of 0 means it arrived first in the system. It arrived at time 0 with respect to the other processes. It doesn't mean that it arrived at, let's say, 12 a.m. Nothing like that. It simply means that it arrived first. All the times are relative times. So process P1 arrived relative to process P2 and it arrived earlier with respect to process P2. Similarly, process P2 arrived relatively earlier as compared to P3. P3 arrived relatively earlier as compared to P4. Right? Now, at arrival time 0 or at time 0, only process P1 is available to the operating system. So it has no other choice. What it will do is, it will simply schedule this process. But for how long will it schedule this process? It will schedule this process till the time another process arrives in the system. Because at that point, it may have to check whether the burst time of that process happens to be lesser or not. So what we'll do is, we can see that process P2 arrives at time interval 15. So we will schedule this process P1 or we'll show it in a NAT chart till time unit 15 and then see how P1 fares against P2. So P1 will be allocated the CPU for 15 units. Right? Now if P1 is allocated the CPU for 15 units as we have shown in a NAT chart, then its burst time or its remaining burst time is 5 units. Now at the 15th unit of time, we can see that process P2 has made its way in the system. Now process P2 has a burst time, it has an arrival time of 15 and it has a burst time of 25. Now, as I mentioned right at the beginning, that the criteria is burst time. The process with lower burst time will be scheduled the CPU first. So since process P1 has a burst time of 5, the remaining burst time rather is 5 and process P2's remaining burst time is 25, P1 will be scheduled. That means P1 will continue executing with the CPU. It will not give up. I simply showed this break so that you can understand how things work in SRTF. P1 will never give up the CPU during its execution. So it will execute for 5 more units. As a result, we get time 20, after which it will finish its execution because 20 units of time has elapsed. Its burst time has elapsed and it will leave the system. Now at arrival time or at time interval 20, we can see that no new process has arrived in the system. But the only process that is available to us is process P2. So what we do is, we scheduled process P2. For how many units? Let's schedule P2 for 10 units because at 30th unit, we can see that process P3 will make its way into the system. And then we can compare P2 and P3. So if we schedule this for 10 units, P2 is left with a burst time of 15. And now P3 has made its way into the system. But here we find an interesting thing. That is, the burst time of P3 is 10 as compared to the burst time of P2 of 15. So P3 will be scheduled ahead of P2. That means the CPU will now be taken away from P2 forcefully. It will be preempted. It will be preempted. The CPU will be preempted from P2 and given to P3 because its burst time, which is 10, is lesser than that of the burst time of P2, which is 15. So 10 is less than 15. Burst time of P3 is less than the burst time of P2. So P3 will now get hold of the CPU, right? And for how many units? Let's say that since it has a burst time of 10 units and the next process arrives at 45th unit of time, we will give P3 its entire burst time execution. That means we'll give it 10 units. So it will run till 40 and give up the CPU and leave the system. So at 40th unit of time, we can see that no new process is arriving or has already arrived. We have only P2 available with us. So what we do is we schedule P2 for how many units? Let's schedule it for 5 units because at 45th unit of time, we will have a contention between P2 and P4. The one with the lower burst time at time unit or at time interval 45 will get hold of the CPU. So let's just schedule P2 for 5 units. So we get 45. Now P2 is left with a burst time of 10. And at this point, at 45th unit of time, process P4 has finally made its way into the system with a burst time of 15. If you compare the burst time of P4 with burst time of P2, you will find that the burst time of P2 is lesser than that of P4. So P2 will get scheduled, or it will continue with the CPU. It will not get scheduled. It already had the CPU. So it will continue with the CPU for how long? It will continue for 10 more units. So it will give up the CPU at 55th unit of time, completing its burst time and leaving the system. Finally, P4, since it is the only process left in the system, will run for the remaining duration of its burst time, that is 15 units, and leave the system. So that will give us 70, right? 55 plus 15, it comes to be 70. Yes, it comes to be 70. So this is my process P4, right? Now, in order to find the waiting time, we need to find the completion time and the turnaround time first. So let's just find the completion time of each process. Now, in order to find the completion time of preemptive scheduling algorithms, always scan the NAT chart from right to left. From right to left. And on the first occurrence of a process time slot, take the ending time interval of that time slot. So let's see how it happens. I'm scanning from right to left. This is the first time I'm encountering a slot for P4. And what is the ending time of that slot? 70. So the completion time of P4 is 70. I hope I'm making sense. Now again, continuing the scan from right to left. Now after crossing P4 slot, I encounter a slot of P2. And I realize that I haven't seen a slot of P2 as of now. So this is the first time I've encountered this time slot of P2. And the time slot is getting over at 55. That means the completion time of P2 is 55. Now again, I see P2. But I have already encountered P2 previously. And I have concluded that its completion time is 55. So I will skip this P2 and move on to P3. Now this is the first time I'm encountering P3 and the end time interval of this slot is 40. So P3 will have a completion time of 40. Finally, we encounter P2 once again, but since we have already visited P2 earlier, we will ignore this. Now coming to P1, this is the first time we are encountering P1. So what we do is we take the end time of the time block. We take the end time of this time block, this entire time block of P1. What is the end time? 20. So the completion time of P1 is 20. And what about turnaround time? Turnaround time is the time interval between which a process enters the system and leaves the system. So complete turnaround time is nothing but completion time minus arrival time. Why? Because completion time denotes the time at which a process leaves the system, and arrival time denotes the time at which a process arrives in the system. And what did I say? Turnaround time is the difference between the point at which a process arrived in the system and the point at which it left. So turnaround time is quite rightly completion time minus arrival time. Although we don't need to find this because we have been asked to find only the total waiting time for process P2. So we can see that, in fact, we have been asked to find the waiting time, right? I mistaken it to be completion time. Anyway, we need to find turnaround time if we have to find the waiting time. So let's just do this. Let's find the turnaround time. It's completion time minus arrival time. So 20 minus 0 will give me 20. 55 minus 15 will give me 40. 40 minus 30 will give me 10. And 70 minus 45 will give me 25. I hope my calculations are correct. If you find any flaws, please leave a comment in the video and suggest the correction as well. So completion time minus arrival time. So 70 minus 45 will give me 25. Right? And finally, I have to find the waiting time. The waiting time is the time spent by a process waiting for the CPU. So the time that it spends waiting for the CPU is called the waiting time, and that is found by taking a difference of the turnaround time and the burst time. Why? Because turnaround time denotes the total time for which a process is present in the system, and burst time denotes simply the execution time, the CPU execution time. So from the total time spent by a process in the system, if I take away the execution time, what am I left with? I'm left with the waiting time, the time that the process waits for the CPU. So waiting time will come to be turnaround time minus the burst time, right? Because turnaround time is the total time spent and burst time is the time spent on the CPU. The remaining time that we have with us is the waiting time. So waiting time, remember, is nothing but turnaround time minus burst time. You can either remember the formula, you can either remember this formula, turnaround time minus burst time, or as I explained to you, you can keep those explanations in mind, and the formula will come to you intuitively. So it's turnaround time minus burst time. So that's 20 minus 20 coming to be 0. 40 minus 25, right? I'll take the total burst time, mind you. I'm taking these values, 20, 25, 10, and 15. So if I take the turnaround time and subtract it from the burst time, what do I get? 40 minus 25 is 15. Similarly, 10 minus 10 is 0. And 25 minus 15 is 10. An interesting thing to note here is we are getting 0 as waiting time for two processes. What does this signify? This signifies that processes P1 and P3 have not waited for the CPU at all. That means whenever they arrived in the system, they got hold of the CPU immediately. So they did not have to wait at all. So this is my waiting time. Now they've asked to find the total waiting time for process P2. So the total waiting time for process P2 is nothing but 15 units. So I hope this helps. Thank you.